Hmm. Okay, hello everyone. Today we're going to be focusing on a parallel circuit. I told you guys that I'll do it before the paper, and here we are. So look nicely through how I'm doing it. And if you have any questions, please feel free to ask me before 9 o'clock today. So this is a typical example of a parallel circuit, right? The first thing we should know is that if we look at current comes out of the battery. What is current? Current is the flow of electrons, right? So electrons flow from the battery, they come out, and this part of the circuit is called series. This entire part in orange is called series. And we know that in a series circuit, current stays the same. So the current and the reading through ammeter 1 and ammeter 4 will read the same thing. And ammeter 1 and ammeter 4 gives us the total current of the circuit, right? So, but what happens in a parallel circuit is that there are more than one branch. So current will come right out of the battery in total force, and then it will break up into the branches. So some parts of the current will go on top here into this branch and all its components, and then some part of the current will go through this branch and all of its components, right? So we learn from that current in a series circuit, in a parallel circuit, always splits, right? That means that if I take this current plus this current, I am going to get the total current. If I had to represent that in an equation, it would look like this. A1 is equal to A2 is equal to A3 is equal to A4, right? No, sorry, what am I saying? Talking nonsense there. What I was actually saying is that A1, that would be correct if it was a series circuit, is equal to A4, right? This guy and this guy are equal. But A1 is equal to A2 plus A3. Because remember, current splits, and then it needs to come together, right? I hope everyone understands that so far. Okay. What else do we need to know? We need to know about voltage in a parallel circuit. So we know that voltmeters calculate or read voltage running through a device. Voltage comes from the battery. Let's look at the definition of voltage. Voltage is how strongly current is pushed through a circuit. Or another definition of voltage is how much of energy is given to electrons as they pass through the circuit, right? Another thing about voltage in a parallel circuit is that it always stays the same. Voltage in parallel always stays the same. That means that if this voltmeter here is reading, if this voltmeter here is reading 12, then this one will read 12, and this one will read 12, and this one will also read 12. Meaning that if I had to represent it in an equation, V1 is equal to V2 is equal to V3 is equal to V4, right? Current is not the same. Current in a parallel circuit always splits. So let's look at our questions. Let's see if we can attempt to do them, right? Question number 1. It says, find the reading on A1 and A4. A1 is all over here. Oops. Is this guy here, right? And A4 is this guy here. A1 is here, A4 is here. A1 and A4 are only the names of those ammeters. They don't give you the reading or the measurement, right? So we know that A1 and A4 are both in series. So they are equal to each other because in a series circuit, current is the same. Which means, how are we going to find this? Right? It's out of 2 marks. So that means there's a little bit of a calculation involved. We said before that current splits in a parallel connection. So if I take the current through this branch on the top, plus the current going through this branch, I should get the total current of both these emitters. So I can say A1 is equal to A4 is equal to, I'm just writing it here at the bottom because I don't have space, A2 plus A3. What is A2 plus A3? A2 is 0,5, A3 is 1,5. And I'm going to get 2 amperes of current. Remember your units. Always remember your units. Okay, and I'm going to write my answer here for you guys. It's 2 amperes. What is the reading on voltmeter 1? So can you see how when I analyzed the circuit at first, I already figured out my answer just by looking at the circuit. By the way, I forgot to mention that a quick side note, whenever I find the answer to a question, I always write down the value for those answers. And I like to use colors. Bring some highlighters when you're writing your exam. And then you can just add what these are, right? So we wanted voltage. So we know that voltage in the parallel circuit is the same. So if V4 reads 12, then V1 will also read 12 volts. V3 will also read 12. V2 will also read 12. So your answer here is 12 volts. Moving on. What is the reading on V2 and V3? We know that in a parallel circuit, V1 is equal to V2 is equal to V3 is equal to V4 is equal to 12 volts. Number 4, what is the resistance on R1? Now, did you see how until now I didn't do a single calculation? I didn't use a single, not calculation, I didn't use a single equation, right, from Ohm's law. This is the only time I'm going to use an equation because there's no other way of finding out R1 besides using an equation. So avoid using equations because most of the time you can figure out the answer by just working out the circuit on its own. So what is my equation for resistance? Let's use a green. I want to find the resistance of R1. I say R is equal to V over I. And please don't forget your Ohm's law triangle. Ohm's law triangle has current here at the bottom, voltage on the top, and R at the bottom, right? So it becomes R is equal to V over I. What is my voltage running through R1? The voltmeter across R1 will tell me the voltage going through it, which means 0.5 amps of current. How much of energy is that current getting, right? And we know that voltage is the same throughout a parallel circuit. So we say it's 12 divided by current. The current going through this branch is 0.5, which should give you 24 ohms, right? You put that in your scientific calculator. What's my rule? As soon as I find an answer, I slot it in there. All right. Next question. You want me to find R2. Right, so R2 is equal to VI over V over I. And we say, what is the voltage across R2? Its voltage is the same in a parallel circuit, so 12 over. What is my current through R2? It's 1.5. And I'm going to get a reading of 8 ohms. And I erase because I'm done. Cool, that felt good. Can you see how I'm going to get 3 marks for that? It's 3 marks, so I need to have enough steps. Number 6, work out the total resistance of the circuit. So this is, I think, the tricky part of parallel circuits, where you need to work out total resistance. So let's look a little bit into theory, right? I love using this example, and you guys know that I always use it. When the more resistors we add in a parallel circuit, so just say you add you switch on your fan and you switch on your stove and you add your charger. Will your fan operate slower because I switched on my charger? Absolutely not. Why? Because parallel circuits are designed in such a way that the more resistors I add in the circuit, the smaller the total resistance becomes. And if you remember Ohm's law, you remember the equation that when resistance becomes smaller, what becomes bigger? Current, because they have a direct relationship. They are directly proportional, right? That means that more current can flow. And when more current flows, that means that no device, no resistor is disadvantaged. Okay, so let's look at how we're going to work out total resistance there. So a total resistance is going to look like this. This is your equation number 1. You have to write your equation. And can you see I have the 1 over each resistor? Think about 1 over that resistor means I'm halving the resistance. I'm making the resistance smaller, okay? Because that's what happens. The more resistors you add in parallel, the smaller or the half it gets. So we have 1 over 24 plus 1 over 8. And if you put this in your scientific calculator, you should get 1 over 6. But I do not leave my answer like this, right? I must, because 1 over 6 is bigger than 1 over 24 and 1 over 8. Am I right? Just a little bit of maths there. But that just makes sense, right? But now I need to inverse. I need to bring 6 to the top and 1 to the bottom. And my answer is going to be 6 ohms. So can you see how the total resistance of the parallel circuit is smaller than even the smallest resistor? The smallest resistor is 8 ohms, but the total resistance is 6 ohms, right? And you should get, I wrote 2, but you should at least get 4 marks for this question because it's worth that much, right? I hope everyone's understanding this, and you will need to use scientific calculators for this because you'll need to use fractions. Please do not put it in decimals unless only your last final answer should be in a decimal form, right? Which bulb burns brightest? Let's see, is it R1 or R2? Well, do you remember what I said about Ohm's law? Ohm's law states, and we know that in a parallel circuit, the smallest resistor will receive the greatest current, right? Because if we look technically at Ohm's law, it looks like this. It makes sense. Current, it's like us. In life, we don't like taking the long, difficult path. We like taking the short path, right? Same thing with current. If there's a lot of resistance, a little current will go through in comparison to a resistor that doesn't have that much resistance, okay? That is going to be your answer. That's what you're going to write for that. You're going to say, which number is this? For number 7. R2 burns brighter because, I'm just writing it in slang here, current favors the path of least resistance. And if you want to get bonus marks, you can always write, explain Ohm's law. So say, according to Ohm's law, when you bring down resistance, or the smallest resistor will receive the greatest current, because current and resistance are inversely proportional. I'm sorry if I said it's directly proportional before. I think I'm just a bit exhausted today. Okay, number 8. Through which resistor will current be the greatest? We already, I think this 7 and 8 are the same answers here. What happens to total resistance if I add 1 more light bulb to parallel? So remember what I said, guys. I said that the more resistors you add in parallel, the smaller total resistance becomes. Okay? Yeah. And if I take away a resistor, the greater total resistance becomes. Hope this lesson was insightful. I'm going to add 1 more question for you guys, and then you guys are going to complete it and let me know what your answers are. Remember, in the paper, I may give you like this current here, but I may not give you this current, then you need to work it out. So let's actually look at that kind of question. I'm going to erase everything that I have here. If I gave you that kind of question in the paper, I told you that the current on this ammeter was 2 amps, and I hid away the current here, for example. How are you going to work out the current on A3? Remember, the main equation was A1, which is the total current, is equal to A2 plus A3, right? But we have A1, which is 2. We have A2, which is 0,5. The only one we don't have is A3. So logically speaking, you're going to say 2 minus 0,5 is going to give you A3, which is going to be 1,5 amperes. And then you can just slot it in there. Okay, so there's just a few ways that I can make it tricky for you guys. But I mean, come on, guys. It's just like there comes a limit to the amount of ways I can make this tricky for you. It's just like so simple in that regard. Like if I gave you 12 ohms here, 12 volts here, and I hid away this, then you obviously know the rule that 12 volt voltage in a parallel circuit is constant, and each of these voltmeters will read 12. Okay. How else could I approach it to you? Yeah, that's basically it, people.